Okay, so that's a class. Okay, first of all, what we're going to talk about, we're going to talk about numbers. We're going to talk about numbers. Okay, yeah, because numbers is a fundamental for all the scientific research. Okay, for the science. It doesn't matter is physics, geology, or even chemistry. We are all start with from the number. Okay, we'll all start from number. So today we talk about number. Tomorrow we talk about what exactly is chemistry it is. Okay, yeah. So let's first talk about number. Okay, so first of all, let's talk about the two definitions. Okay, the first one, maybe you already heard of that. Is the difference between precision and accuracy. Precision versus accuracy. To be honest, as a foreigner, I have no idea what is the difference between those two because the translation actually is the same. Okay, until I'm teaching chemistry, I know the difference. Okay, chemistry, the precision and accuracy, they all talk about how accurate or how precise your data it is, but they have a little bit different. Okay, this data is talk about different things. Okay, yeah, when we talk about and just give you one example, then you probably know what's going on here. For example, we have a brand new tables over here. This table set up I think at spring, sorry of this year. So when this table coming out of the factory, they have instruction, right? And the instruction should shows what is the length of the table. That makes sense, right? It should shows the length of the table. So for example, if we have a table, now the length of the table, the instruction shows, okay, the length of this table, it shows is 1.5 meter, okay, although it's not accurate, but that's 1.5 meter. This data, you can compare this data as a literature data. Okay, because this is coming from the factory. It's not the data that you measured. Okay, remember, the data you measured is called the experimental data. And this is, you can compare that as a literature data. And then we have three different students. Okay, we have student 1, student 2, and student 3. And the 3 students, they're going to measure the same table, okay, with the ruler. Okay, the first student, they measure the table is a 1.71 meter. The other one is measure 1.72 meter. And the third one measure is 1.69 meter. Okay, so those 3 students measure the data. But obviously, you see, this data has a distance. It's a little bit far away from 1.5 meter, which is coming from the literature data, right? Okay, but if you look at this set of data, well, those set of data is repeatable. 1.71, 1.72, 1.69 is similar, right? Yeah, so the precision is talking about the experimental, so those things, you can count this as an experimental data. That makes sense, right? Because this is what a student measure. If the experimental data is repeatable, just like this, and we call this data is a precision, is precise. This data is precise, okay? But this data is not accurate because this data is away from 1.5, which means the experimental data is far from the literature data, and we call this is inaccurate or not accurate. That makes sense, right? Okay, so if we call this set of data is precise, but not accurate. That makes sense, right? Precise but not accurate. So this is the set of data. And if you draw the graph in a target, and then you will see, okay, this set of data could be have a sum of the data shows over here, and those group of data are repeatable because they close to each other. But it's from far away from the target. So we call this data is precise but not accurate. So this is precise but not accurate. Okay. So what happens for precise? Can you imagine that? What is the precise and accurate? What is the precise and accurate? Yes. So that means you're gonna have the data probably like this, right? Yeah. You have a group of data. Those are close to each other, which means it's precise, and also is close to the target, which means it's accurate. Are you clear? So precise is talking about the group of the data in the experimental data, how they can repeat to each other. Accurate is talking about how far away the experimental data from the target literature data. Okay, so this is precise and accurate. Okay, so how about not precise and not accurate? And there's another is precise, yeah, accurate, but not precise. Okay, so let's talk about this target. If we say not accurate and not precise. So if it's not precise, which means we're going to have a data all over the target, right? Yeah, and then this one is not accurate and also not precise because it's far from the target, and also the data is not repeatable. Okay, so this is not precise and also not accurate. Okay, yeah. So can you imagine the last part maybe is hard to understand. Can you imagine? Okay, it's a precise, it's accurate, but not precise. It's accurate, but not precise. Okay, yeah, some of the data is scattered. So those data is scattered, but it's still close to the target. Okay, it's close to target, but it's scattered. Okay, yeah, so this is the precise but accurate. Okay, hopefully you can see the difference between those two. Okay, so this one, the data aggregate together, but this one is scattered, but it's all close to the target. Gotcha? Okay, so those are 4 different situations about the precise and accurate. Precise is talking about experimental data itself, how repeatable it is. Accurate talk about how far it away from the literature data. Okay, precise and accurate. Are you clear? Okay. All right, so the next part, we're going to talk about the sigfig. It's called a significant figure. Okay, you can short for sigfig or short for SF. Okay, those are the same thing. Okay, significant figure, sigfig, or SF. Those are talking about the same thing. Okay, so first of all, let's talk about one situation, why we need this. Okay, yeah, I prefer talk about why. Okay, that's because, okay, you need to understand the reason. I mean, for me, If I understand the reason, and it's more understandable for the following questions, for the following stuff. Okay, if I just know how to do the work, but don't know the reason, sometimes I will stuck there because I just cannot imagine why the people have to do so. Okay, is there any way to do the same thing, right? So we have to talk about why we need the significant figures, why we have to learn this. Okay, yeah. Is there any way? Well, so let's talk about situation, one of the situation. So there's a one day I drive back from Dallas to Wichita. Okay, I'm on the way to home, and then my wife gave me a call, and she wanted me to know where I am on the highway, right? And I see the sign on the road, on the side of the road. It said it's a 150 mile away from Wichita. So this is a 150 is the number, right? And if I look at the Google map, it also shows the number, right? It shows 147 mile, right? And I believe there's a more accurate data. It shows 147.13 miles away from Wichita. Well, I mean, I can give my wife a number. Well, either way, we can choose the number. I say, I'm away from Wichita 147.13 miles, okay? And she probably will pause there, think about what's going on with you. Do you have a head damage or something? Okay, yeah, because I mean, she don't need those accurate number, right? She just want to know rough number, okay? And she can adjust, okay, so when she can cook the food and want to come home, right? So that's why, okay, you may think about the easy number, and somebody may think about the hard number, the more accurate number. Okay, so which number we're gonna choose? That's gonna be a problem, right? So that is why people need a rule for everyone, especially in the science area. Everyone will follow the same rule. Then we will talk in the same topic, right? Everyone will be in the same page. Okay, you cannot compare the banana with the apple, right? You have to speak banana and do the banana and eat banana, okay? So everything gonna be the same. Okay, so this is the rule for the sig fig. That is why we need a sig fig, because we need to make sure everyone do the same thing. All right, so that is why, and then let's talk about the rule. All right, so the rule number one is talk about, okay, so all numbers in the future, I'm going to write this as a number. So all numbers are significant. The significant means when you count the sig fig, you're going to count the number. For example, so that is a pi number, right? So all those are numbers, then you're going to, each of this will count. So this guy, this has a 3 sig fig. They have a 3 sig fig, okay? So this is the rule number one. Rule number two is talk about all zeros. All zeros are between numbers are significant. Okay, so for example, we have a 2022. Okay, so 2022, this 0 is in between the numbers. So this guy also count as a sig fig, and all the numbers also count the sig fig. So this guy has a 4 sig fig. And if you talk about 2002, and then we have 2 zeros. And those two zeros also between two numbers. So those two zeros also count as a sig fig. So this guy also has a 4 sig fig for 2002. All right. Okay. So this is rule number 1 and rule number 2. Rule number 3 is talking about heading zeros. Some of you probably already heard this before, and just to emphasize that heading zeros are not significant. Heading zeros are not significant. So in what situation we have heading zeros? Only the situation when we have decimals, right? When we have a decimals, like a 0.0020. Okay, no, let's see this. Those are all heading zeros. Just to make sure, not just the first zero before decimal point is a heading zero. It's everything before the number are all heading zeros. Okay, so this zero not count, this zero also not count, this zero also not count. So for this number 0.0002, they only have a 1 sig fig. Okay, only these two are significant. Okay, so they only have 1 sig fig. Are you with me? Okay, yeah. So it doesn't matter, you have like a 0.2, this guy has 1 sig fig. 0.02 also has 1 sig fig. 0.0002 also has 1 sig fig. Okay, the heading zeros are all not count. Rule number 4 is a little bit confusing, but I hope you can. I'm going to separate this one sentence. First sentence is talk about trailing zeros. Trailing zeros are not significant. Then unless this is another part, unless decimal point is shown, is present. Okay, trailing zeros are not significant unless decimal point is present. Okay, so what does that mean? Sometimes it's confusing. For example, if we have like a 2000, okay, 2000, or you say 20, 20, 20, okay? So this number, those are trailing zeros of the number, right? This zero also the trailing zeros, okay? Yeah, so trailing zeros are not significant if there's no decimal. So those two numbers do not have a decimal, so those zeros are not count, okay? So that's why the first one, 2000, only have 1 sig fig, and those two, 2020, those are significant, okay? First, number are significant. Zeros between number are significant. So this guy has a 3 sig fig. Are you with me? Okay. All right. So then let's talk about, okay, so if we have a decimal present, which means if we have a decimal shows over here, 2000 dot, then we have a decimal present in this number, which means then those zeros will count as a sig fig, as a significant figure. Okay, so 2000 dots will have a 4 sig fig. Of course, the dot don't have to be every time in the end. Okay, if you have a dot in the middle, those sig fig zeros also count as a sig fig. Well, but obviously those two are not equal to each other, right? This is 2000, this is 20. Okay, so those are two different numbers, but they have the same sig fig, right? So this guy has 4 sig fig, 20, this number also has a 4 sig fig. All right. If you put like a 0.02000, well, in this case, the decimal is in front of the number. Well, then based on the rule, heading 0 doesn't count, right? Trailing zeros, once we have a decimal, those are count. So the 0.02000 also has a 4 sig fig. That makes sense? Okay, so this is how we count the sig fig, and we have 4 different rules and counting that. So now next part will be our practice time. Okay, so that next time we're going to practice. So go ahead, write down. We have the turn to the page 5 in the study guide. And please go ahead to write down the sig fig for the question 1 from A to I. Okay, question 1 from A to I. You can write this on the study guide. That's fine. Okay. From A to I. Okay, so let's review those questions. A, that's gonna be 4 sig fig, right? B, that's 5 sig fig. C has a 3 sig fig. D has 4. E has a 3. F has a 4. G has a 5. H has a 2. And I has a 3 sig fig. Okay, yeah. All right, so this is a kind of a practice. Just let you be familiar with the sig fig. Okay, and the next part, we're going to talk about how to cut off the numbers. Okay, how to make the correct sig fig. Okay, from the given numbers. For example, the pi number. How many numbers can you remember after the dot? 3.14. Okay, so this is how much that I can remember for the pi. Okay, but obviously you don't need that much, right? But how can we cut those long tails to get the required numbers? Okay, so this is what we're gonna do. For example, if we want the number only 5 sig fig, if we only got 5 sig fig, then what we're gonna do? You're going to start the left side and count 5 numbers to the right. 1, 2, 3, 4, 5. Okay. And then you look at the sixth one. The 6 is 9. And then if everything, the number above 5, you're going to round it up. Okay. So now you're going to round this up, and then you're going to cut off everything, the rest of that. Okay. So the answer will be 3.1416. And this is give you the 5 sig fig for the pi number if we keep 5 sig fig. Okay. And how about 7 sig fig? If you want to keep 7, again, 1, 2, 3, 4, 5, 6, 7, and you look at the 6. The next one, the eighth is a 6. You're going to round this up, so the number will be 3.14153. Okay, so go ahead to write down how to cut. We got 9. If we have a 9 sig fig, we need the number has a 9 sig fig, and then what's the number it's gonna be? Okay, that's gonna be a 3.14159. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. 9 is a 5, and look at the next one is a 3. So the 3 is less than 5. You're gonna cut off everything, and just 9, 2, 6, 5. Okay, and then that's gonna be the pi number with the 9 sig fig. Pretty easy, right? Not hard. Okay, the hard part is not for the decimals. Okay, the hard part for a whole number. So if I give you a whole number, how to run those numbers? Okay, so for example, if we have 1, 3, 1, 4, 6, 1, 5, 9, 2, 6, 5, 3, 5. Okay, let's just stop here. If we have this number, this is going to be 31 billion something, right? So if we want to run this number, okay, so if we want 5 sig fig for this number, then what are we going to do? Again, you're doing the same thing. Count from the left to the right. 1, 2, 3, 4, 5. And then you look at the next one. Next one is a 9. Okay, so you round it up. Then you're going to write 31416, and then what are you gonna do? Please do not cut off the rest of the others. If you cut off the rest of others, you're lost the numbers, the different value. Originally, you got a 31 billion something, right? Once you're cut off the rest of this, what do you have? You only have a 31,000. So those are not the same number, right? You're lost. This is completely different. Okay. Yeah. So you have to find a number very close to it. Okay. Then what are you going to do? You are going to fill zeros after that. So you're going to erase all of those, and then you fill the zeros. How many digits you're delayed? And then you're going to put zeros on each of the digit positions. Okay, so this is how you run it. So you get rid of 6 of the numbers, and then you're going to put 6 zeros. 1, 2, 3, 4, 5, 6. Then they see we still got a 31 billion something, right? Yeah. So at least you didn't lose too much of the value. So when you round up the number should be still close to the original number. All right. Yeah, this is the key. All right. Then let's see. If you want to have a 7 sig fig for this number, Again, you count. You count 1, 2, 3, 4, 5, 6, 7. The next one is a 6. 6 is gonna round it up, but you're going to get rid of the 6, right? So you're right. This is 3, 1, 4, 1, 5, 9, 3, because the 6 is round up. So the 2 becomes 3. And you get rid of a 4 digit, you're gonna add 4 zeros over here. And then if you count here, you still got 31 billion something. Okay, yeah, this is for whole number. The whole number, you cannot get rid of get rid of those part. You have to fill zeros. That's it. Are you clear? Okay, yeah. All right. So this is talking about how to round up the numbers for the decimals and also the whole number. The next part we're going to talk about another one is called a scientific notation. You probably already know what is the scientific notation, okay? And just to remind you, the scientific notation including 2 parts. The front part is called a number part. The other part is called the exponential part. So those 2 parts, the first part have to be a number, but this number have to be from 1 larger and or equal to 1 or smaller than 10. So generally this number have to be between 1 to 10. Okay, 1 to 10. And for the exponential part could be a positive number, could be a negative number. If it's a whole number, definitely this is a positive number. It has a decimals, then the definitely is gonna be a negative number. Okay, so if you have a decimal, definitely is a negative number. If you have a whole number, definitely is a positive number. Okay, yeah. So for example, if we have 2021, okay, 2022, these numbers, okay, yeah, you can simplify, which means you're moving the decimal from here is 1, 2, 3. So you're moving off here, moving 3 times. Then the scientific notation for this one is going to be 2.022 times 10 to the 3. Okay, 10 to the 3, that's a 1,000. So 2.022 times 1,000, that's going to be the same numbers. So in another word, if you're changing the scientific notation, the value of this number should not change. Okay, the value of this number should not change, should be the same. Okay, should be the same. Okay, if you have like a 0.0002022, okay, if you want to change this as a scientific notation, then I recommend, okay, for a decimals, I recommend just to me, the easiest way to write the exponential part is to look at, okay, so this is a decimal, so definitely they're gonna be negative sign, okay? And then you just count how many zeros it has. It has a 1, 2, 3, 4, including the 0 before the decimals, okay? We have a 4 zeros, then that's one is, then you can write that's at 2.022 times 10 to the negative 4. That's it. Okay, yeah, that's it. So this is a scientific notation. I know you already know the scientific notation, but some of the cases people got confused, especially, okay? So let me just write down this number, 2022. You can write 2022 as a 0.2022 times 10 to the 4th. You can write 2.022 times 10 to the 3. You can also write 20.22 times 10 to the 2. You can also write 2.022 times 10. Okay? all of those, if you're time the number and the exponential part, the value should be the same, okay? But only this one is called a scientific notation. It's because the scientific notation, the value here, the number part, have to be between from 1 to 10, okay? So that this is the scientific notation. So for the rest of others, although they have a same value just like this, but those are not called scientific notation. Only this one is called a scientific notation. Got it? Okay, so very important. Okay, I know some people will be confused about this. And also, if you want to count the sig fig for the scientific notation, only looking at the number parts. Okay, for example, if you look at the page 5, question 1, JKL, then you just look at the scientific notation part, the number part, then you will know the sig fig. The J 1.04 times 10 to the 12. And the sig fig is just 3 because 1.04 is the 3 sig fig. 5.59 times 10 to the negative 7, you can just write this guy has a 3 sig fig because the number part has 3 sig fig. Are you with me? Okay, so this is the talk about the scientific notation. All right, so let's take a break. Okay, yeah. Let's take a 5 minutes break. I know you're tired, especially in the afternoon, right? Okay, so let's come back. Okay, let's do 3 questions, three numbers. Okay, so first of all, let's do 2 steps. First of all, round those each of the number to 3 sig fig and change that to the scientific notation. Okay, round those 3 numbers into to 3 sig fig and then change that to the scientific notation. All right, yeah. Okay, change those 3 numbers to the 3 sig fig, and then change that to the scientific notation. Okay, got a 3 sig fig for each of the digit number, and then change that to the scientific notation. Yeah, change those 3 numbers to 3 sig fig first, and then change those 3 sig fig number to the scientific notation. Are those tricky? Okay, so let's talk about this. Okay, the first number actually is a tricky one. Okay, again, we need to first change every number to 3 sig fig first. You remember when we talk about pi, how to got the 3 sig fig? You count from left to the right, and you got 3. 1, 2, 3, and look at the next one. Next one is 1. So you can cut off, since this one is a decimal, so you can cut off the tail. So once you change this number to 3 sig fig, that's going to be 3.22. That makes sense, right? Okay. And how about this one? If you count 3 sig fig, you're going to have 1, 2, 3 over here. Okay. And since this is a whole number, okay, do not have a decimal. So you look at the next one is a 1. So you need to remove those stuff. But since this is before the decimal, so you're going to fill zeros in these positions. Okay. So this one is going to be a 3, 2, 2, 0, 0. That makes sense, right? Okay. And for this number, again, you look at 1, 2, 3, and then look at the next one. The next one is a 7. So you're going to round it up and then get rid of that part. So the number that's going to be 4, 1, 6, and fill the 0 over here. Okay, yeah. So now this is the 3 sig fig from those numbers. And then you're going to write the scientific notation from those numbers. Okay, yeah. Again, scientific notation, we talk about this, including number parts and exponential part. Okay, so and the number parts have to between from 1 to 10. Have to between 1 to 10. Okay, so then let's look at this number. Is the number already be 1 to 10? It's already 1 to 10, right? From 1 to 10. So you just write this is gonna be just the number parts, and you're gonna time exponential. Something times 10 to the something equal to the same thing. And that's gonna be 0, right? Because 10 to the 0 is 1. 10 to the 0 is 1. So that's gonna be the scientific notation for this. Okay. And again, for this one, you're doing the same thing, right? We want the number parts be from 1 to 0. So if you move this, the decimal over here, 1, 2, 3, 4, you're moving 4 times. So that's going to be 3.22 and the time 10 to the 4th, because we're moving 4 times, right? 10 to the 4th. And this one, again, that's moving 1, 2, 3. So we're moving 3 times. So that's a 4.16 times 10 to the 3. And again, you're going to keep the same sig fig, okay, from the original. The original, this guy is a 3 sig fig. This is also 3 sig fig. Those are also 3 sig fig, right? So you keep then, so that's why you're going to write the 3 sig fig for the decimal, for the number parts, and write the different exponential. Keep the value the same. Keep the value the same. That's it. Okay, yeah. The exponential part is just to try to keep the value, those two values are equal to each other. That's it. Okay, yeah. And we just need try to make those front number parts between 1 to 10. That's it. All right, yeah. All right, any questions? No question? Okay. All right, so then let's talk about, okay, the next part. The next part will be the calculations with the sig fig. Okay, we're going to talk about the calculation with sig fig. Calculation with sig fig. Okay, first of all, let's talk about the multiplication and the divisions. So the multiplication and the division is those two are similar and easier. Okay, yeah. So for example, let's look at one of the example in the page 5 study guide, page 5, question number 5. Okay, A, we have a 2.89 centimeter times 4.01 centimeter. Well, this is a modification with the unit. Okay, yeah. So generally, what you do, you have the number multiplied together and a unit multiplied together. Okay, so this is a 2.89 times 4.01 and centimeter times centimeter. So the centimeter times centimeter, that's gonna be just a square. Okay, centimeter square. And then we're going to do the calculations. So in general, if you do the calculation in the calculator, it's pretty easy, right? Just 2.89 times 4.01, and you got a number, 11.5889. But the point is, those has too many decimals, okay? Yeah, you cannot have that much of the numbers. Those are generally, those are not accurate numbers. Okay, so we have 11.5889, 11.5889, and this is a square centimeter. Okay, how do we need to round? We need to round this number and keep the correct number. When we do the multiplication and the division, the rule for this is keep the least sigfig. Okay, keep the least sigfig. What that mean? Keep the least sigfig. Is this least sigfig is talking about the number that's doing the calculations. Okay, yeah. For example, this number 2.83 has a 3 sigfig. 4.01 also has a 3 sigfig. Okay, so 3 sigfig times 3 sigfig, the end should also has a 3 sigfig because the least sigfig is 3. Okay, so the answer will be only keep 3 sigfig. So now you need to cut the number, right? You need to cut the number. So again, we need to keep 3 sigfig for this number. In another one, you count from the left to the right. 1, 2, 3, and look at the next one. Next one is 9. So you're gonna round it up, and then you can get rid of those because you have a decimal shows over here, so you can cut off the rest of. Then that's gonna be 11.6 centimeter square. Okay, so now you're keeping 6 sigfig, and also you're having the unit. So that's 11.6 square centimeter square. Are you with me? Okay. Then let's look at the next one, another one. 17.2 centimeter times 6.2 centimeter, which is the B in question number 5. Okay, B in question number 5. Again, that's gonna be 17.2 times 6.2. Oh, 17.3. Okay. Then the unit is gonna be a centimeter square. Okay, so those two times together, 17.3 times 6.2, and you got a number 107.26. 107.26 centimeter square. Okay, so now then we're going to keep the least sigfig. This guy has 3 sigfig. This guy has 2 sigfig. So we're going to keep 2 sigfig for the final answer. Then how to keep this 2 sigfig? Well, hopefully you still can read it. 1, 2, right? We keep 1 and a 0, and look at the next one is 7. Next one is a 7, so you're gonna round it up, and then you're going to keep those number is 1, 1. That's for sure. And then what are we gonna do? This is 107, right? You run up, that should be 110, right? Not 10. That makes sense, right? Because you're going to fill zeros on the single digit part. And then you can get rid of everything after the decimal. Does it make sense, right? Yeah, you need to keep the value similar to the original one. Yeah, you cannot, I mean, you cannot do the rounding and lose a lot of numbers. And that's gonna be the result. 11, 10, they only have a 2 sig fig. Or you can write as a scientific notation, right? You can write this as a 1.1 times 10 to the 2 centimeter square. This is also fine. That is just a number, right? This value is the same value, just like this. And this keep 2 sig fig shows over here. Okay, yeah. And then let's talk about one of the divisions. Okay, let's talk about one of the divisions. They're doing the same thing. 8.071 square centimeter divided by 4.21 centimeter. Okay, so that's a division. Again, you put that into the calculator, 8.071 divided by 4.21. And you got a really, really long numbers. Well, definitely you don't want to write everything in your result, right? You need to keep the correct number. Again, this is division. So you're going to keep the least, the sig fig, right? So the top one has a 4 sig fig, bottom one has a 3 sig fig. Then you're going to keep 3 sig fig for the final answer. So this is a 1.9171. Let's just see, 1.9171. So this has a 5 sig fig, but we only need 3. So keep 1, 2, 3, and look at next one is 7. So you round it up. The answer will be just 1.92. Yeah, centimeter. Okay, centimeter square divided by centimeter. That's gonna be just centimeter. Okay, yeah, I know. If you cut off the decimals, it's much easier, right? But if you're something refer to the whole number parts or the decimals, the number before the decimal, then you need to think about, you need to fill the zeros. Okay, you need to fill the zeros. All right, so this is talking about the decimals. Okay, this is talking about the multiplication. The next part is going to talk about additions. Addition and subtraction, that's a different. Addition and subtraction, they also has a rule, but the rule is to keep the least number of a decimal. Keep the least number of the decimals. Okay, what that mean? Then let's look at one of the example. Okay, let's go to the 2A in the study guide. Okay, so 12 centimeter plus 0.031 centimeter and the plus 7969 centimeter. Okay, so that is addition. So generally, what you're gonna do, you just put everything in your calculator, and then we're going to cut off 12 plus 0.031 plus 7969. And this is your number, 7981.031. Okay, so then that's going to be a centimeter. Addition, the centimeter is just taking out. All right, Now, how to keep this number correct? We talk about this, keep the least number of decimal. What does that mean? Keep the least number of decimal. You just look at each of the original number, it shows up here, and we see how many digits, how many decimal for each of this. Okay, and then we keep the least decimal. Okay, so some of the numbers, the smallest number of the decimals is just 0, right? For a whole number, they don't have a decimal. So that's just a 0, right? So for example, 12 here, they do not have a decimal, they have a 0 decimals. There's a 3 centimeter, there's 0.031. They have 3 numbers after the decimal, so this guy has 3 decimals, right? And then this number is also a whole number, so they do not have a decimal. And then you add them together in another word, you're going to keep 0 decimals, which means it's just a whole number, right? Yeah, so that's why if you look at this, you're going to keep the number in this area, right? And then you're going to look at the next one. If the next one is bigger than 5, you need to increase it. If it's smaller than 5, you cut it off. So this one is just 7981 centimeter. That's it. 7981 centimeter. There's no decimals over there. There's no decimal shows up here. Okay, yeah, so this is how we do the addition and subtraction. Well, this is also makes sense. So if we have, for example, if we have a 1 and plus a very, very small number, 0.0001. So what do you think? What is the answer? 1. Yeah, it's just 1. Okay. For example, you add them together is 1.0001. Okay. And then if you're talking about this is addition, so you're going to keep the smallest decimals. This guy has no decimal, and this one has 4 decimals. So we're going to keep the least decimal, which means no decimals. So 1 plus 0.0001 is just equal to 1, which means it generates no change. A very big number plus a very, very tiny numbers, eventually just no change. Okay, that makes sense, right? Yeah. Yeah, just like if you have a pool of water, you just add 1 drop of water in the pool of water. Generally, it doesn't change anything. That makes sense, right? So this is how we do the calculations. A lot of things you need to round because the 0.0001 actually, it didn't do anything to the big number. Okay, it didn't do anything to the big number. Okay. All right, so this is the addition. Subtraction, you do the same thing. Okay, subtraction, you do the same thing. It just add them together and keep the least decimals. That's it. Keep the least decimals. I know this is confusing, right? Start to confuse yourself, right? I'm just curious, when should we stop? 45, right? 55. Okay, yeah, we still have a little bit of time. Okay, yeah, let's take a break. So just think about this. Just give you a little bit of digestion. Digest this content. Okay, what is the multiplication and division? What is the addition and subtraction? Okay, so now go ahead, work on the question 2B. Okay, work on the question 2B and 2C. 2B and 2C. Okay, so let's look at work on those. So what do? Just plug everything into your calculator. So now, okay, what's going on? Okay, 0.085 plus 0.062 plus 0.15. Okay, so now we got a 0.287. And then let's look at which one is the least decimals. This guy has a 3 decimal, this guy has a 3 decimal, and this has a 2 decimals. So you are going to keep 2 decimals because that's addition, right? So this guy has a 3 decimals. We're going to keep 2 decimal, okay? 0.287. 0.287, this is centimeter. So we keep 2 decimals, which means we're going to keep over here, right? Then you need to look at the next one, okay? You need to look at the next one. The next one is a 7, so you need to round up. So the answer should be 0.29 instead of 0.28, okay? It's 0.29 instead of 0.28. Okay, yeah. So the next one, again, just added the numbers, 3.419 plus 3.912 plus 7.0518 plus 0.0013. So 14.38293. 293. All right, so now this guy has a 3 decimal. They have 3 decimal, that has a 4, and this is a 5. So we're going to keep 3 decimals. So keep 1, 2, 3. We're keeping over here. And look at the next one, which is 9. So we need to round up. That's going to be 14.383. Okay, and then that's going to be in gram. All right, so that's addition. Okay, that's the addition. Modification, I think is more easier. Okay, so this is what we talk about: modification, division, subtraction, and additions. The last part, and this is the last part we're going to talk about, is how can we? What if we have a combination between addition, subtraction, modification, and the division? They combine them together. Then what we do with it? And this calculation is a little bit complicated, just to let you know, a little bit but I try to make it easy. And to be honest, in the exam, I'm not going to give you too complicated calculations because it doesn't make sense, right? This is just, I mean, for the Chem 1 and Chem 2, in general, we're just scratching the surface for all the content, right? We cannot talk about them too much in detail, okay? But I have to talk about this, but won't be too hard on that part. All right, so let's talk about something. We have addition, and then we do the modification. So we have 3.2 plus 4.33 and time 1.22. Okay, so what if we have this number? Okay, so obviously we have to do the subtraction first, and then we're doing the modification, right? So generally, what you need to do is just follow each of the rule. Subtraction going to follow the subtraction, on the addition going to follow the addition rule. And then the modification is going to follow modification rule. Okay, so here we have a 3.2 plus 4.33. 7.53. Okay, so we got a 7.53 here. And this is the addition, right? So how many sig fig we need to keep? Not how many. This is addition, so we're going to keep the least decimals, right? This guy has 1 decimal, this guy has 3 decimals, so we should keep 1 decimal, okay? In another word, we should keep the number over here, right? We should keep the number over here. And then the number should be 7.5 instead of 7.3. So 7.53. Does it make sense, right? But here's the but. Okay, and so here is the why. If you combine everything together, it's confusing. It's because of but. Okay, the but thing is, in the whole calculations, we're not going to round up when we just in the middle of the calculations. So 3.2 plus 4.33 is in the middle of the calculation, right? We're not got the final calculation. It's just in the middle of calculation. So you cannot round the numbers at the middle of the calculation. If you round this number, then the final answer will be quite a little bit, well, it's not accurate. It's off from it's supposed to be, right? So then what are we gonna do? We're going to keep 3.53, 7.53, this number, but you need to keep that in your mind. Okay, this number actually only have a 2 sig fig instead of 3 sig fig. It's supposed to be 7.5, but not 7.53. Okay, so although we're not going to round this number, but you need to keep that in mind. This number suppose only just a 7.5, which means they should only have a 2 sig fig. All right, yeah. So you need to keep this in mind. This guy should have a 2 sig fig. The reason why you need to count this, because you need to time these numbers, right? And when you do the modification, what is the rule? keep the least sig fig, right? Yeah. So if you're not to keep this in mind, then you count this as 3 sig fig, then you time another 3 sig fig. You should keep 3 sig fig, right? But this number, suppose, is a 2 sig fig. So the final answer should only keep 2 sig fig. This is something very confusing. I know it is confusing. When I do the first time do this, I even got confused. Okay, yeah. And okay, so and also just to let her know, hang in there. Okay, if you got everything if you got something confused, okay, ask me. I will make sure you will be clear. Okay, yeah. I like to spend time and to share things with you. Okay, make sure you be clear. Okay, so this is very important. And to be honest, when I take Chem 1 at the first time, I got really bad grade. Okay, I barely passed the class. Well, that's because I take the class in the university, and you know the university usually have very big classes. Okay, so 100 people doing together. So and also I was shy, so I don't have a chance to ask questions, and I just want to figure out by myself. Well, yes, you can solve the problem on your own. And also you can watch the YouTube videos. But the point is, you probably spent like 1 hour or even more. Just if you're asking me the question, probably 1 minute, 2 minutes, you solve the problem. But you probably need to spend much more time to search on the YouTube. Okay, so ask me the question. That's very important. Okay, yeah. Okay, so let's keep going on this part. So now we have 7.53 times 1.22. So you got 9.1866. 9.1866. Okay, so now we said this is a modification, right? So we should keep the least sig fig. So this guy has 2 sig fig, this guy has 3 sig fig. So eventually we're going to keep 2 sig fig for the final answer. Then that's going to be 1, 2, and then you look at the next one, which is 8. So the final answer will be 9.2. Okay, that's going to be 9.2. Does make sense, right? So generally, this is how we do the modification and the addition together. So you're gonna follow each of the rule. Addition, subtraction, follow those is rule. Modification, division, you follow their rule. Okay, but you need to keep your mind how many sig fig we're gonna keep, and then you're going to use the not rounded number to do the following parts. And then you're gonna round at the very end. Okay, yeah. So generally, this is pretty much everything I'm going to talk for today. Okay, pretty much everything we're gonna talk for today. Yeah, suppose actually we should stop at 3:45. Okay, yeah. So I'm going to. It's about like 1.5 hours. Yes.
I just found out from one of my other teachers, apparently there's a problem with Connect right now.
Really?
Hang on.
There's a problem with the Connect. Anyone? So.
There's something wrong with like the publisher itself.
Okay.
She said they're working to fix it right now.
Okay.
I just figured since this class is into, I might let you
So
know.
if you have a computer, you can do right now and see whether it's working or not. Okay.
It's a problem with the website demanding an access code when you try to use the link on Canvas.
Well, they probably can solve that. Very soon. But we don't have the online exam and the pre-reading something until next week, so you don't have to worry about it. I just want you to make the connect, okay, in this week. All right. Yeah, I will double check with you on Wednesday. All right. Okay. All right. So have a good day. Are you ready for the whole semester?
Hope so.
Hope so, yeah. Okay, yeah. I'm going to post the video online. Yeah, so if you want to double check the video, you can double check the video, okay? Mhm.
I can access.
You can